In 2025, a telescope pointed at the deepest patch of sky we've ever photographed and counted which way galaxies spin. They shouldn't have had a preference. Half clockwise, half counterclockwise. That's what 50 years of physics predicted. Instead, 2 out of every 3 spun the same way. Nobody expected that. Nobody has fully explained it. And by the end of this video, you'll understand why that single observation might be the smallest of 6 separate cracks currently running through everything we call the universe. Here's where we're going. We'll watch 2 different measurements of how fast the universe is expanding refuse to agree with each other, no matter how many times scientists check their math. We'll look at galaxies that are too massive to exist, sitting in a place in time where nothing that heavy should have been built yet. We'll find a shape a billion light years wide that isn't supposed to be possible at all. And at the end, we'll ask the question these 6 cracks all point toward. Together, a question most people watching this will never have let themselves ask. What if the universe was never what we assumed it was, even in the parts we thought we understood best? You already know the basic story. Everything, all of it, used to be one point. About 13.8 billion years ago, it stopped being a point. Space itself started stretching, and it hasn't stopped since. We know this because when we look at other galaxies, their light is shifted, stretched toward red, the signature of something moving away from us. Every direction, every galaxy, all of it retreating. Quick question before we go further. If you had to guess, right now, how fast do you think the universe is expanding? A number. Any number. Hold on to it. Because here's the uncomfortable part. Scientists have 2 very good ways of measuring that number. And for over a decade, those 2 methods have refused to agree. Problem: we need to know how fast space is stretching. Temporary explanation: measure the oldest light in the universe, the cosmic microwave background, radiation left over from 380,000 years after the beginning, and calculate backward. That gives you one number. Bigger problem: measure nearby stars and supernovas directly, using them like mile markers on a highway, and calculate the expansion rate from actual, present-day distances. That gives you a different number, consistently, every time, for over a decade. Picture 2 clocks, both extremely precise, both built by people who know exactly what they're doing, and they will never agree on what time it is. Not because either clock is broken, because something about the room they're both sitting in doesn't add up. The gap between those 2 measurements has now reached a level of certainty scientists usually reserve for actual discoveries, not for errors. Which means one of 2 things is true. Either there's a mistake hiding somewhere that nobody has found in 10 years of searching, or dark energy, the invisible force stretching space apart, which we don't understand to begin with, doesn't behave the way we assumed it did. And it turns out, that second option just got a lot more likely, because in 2024, a machine mapping 11 billion years of cosmic history found something that shouldn't have been possible at all. Dark energy might not be constant. It might be getting weaker. The instrument, called DESI, has been quietly building the largest 3D map of the universe ever made, and when its data was combined with older measurements, a pattern emerged. The force pushing galaxies apart appears to be losing strength over cosmic time, not disappearing, just thinning, like pressure slowly bleeding out of something that was never supposed to leak. We haven't even gotten to the strange part yet, because a mismatched clock and a leaking force, as unsettling as they are still just numbers disagreeing with numbers. What comes next isn't a disagreement, it's a photograph. A real image, taken by the most powerful telescope ever built, of something that flatly should not exist. If dark energy is already behaving differently than we assumed, what do you think happens when we point our best telescope at the very edge of time itself and find galaxies that had no right to be there yet? Here's the scene. July 2022. The James Webb Space Telescope has just sent back its first deep images. An astronomer is scrolling through them, half expecting faint smudges, the kind of blurry, early galaxies theory predicted for this period in cosmic history. Instead, there's a small red dot on the screen that shouldn't be possible. She runs it through the analysis software. Distance, 13.1 billion light years. Mass, 100 billion stars. She said later she nearly dropped her coffee. That galaxy existed when the universe was less than 5% of its current age, and it was already carrying the mass of a fully grown galactic monster, the kind you'd expect billions of years later, not in the universe's infancy. Imagine finding a fully grown adult in a hospital nursery, not a big baby, a grown adult, somehow already standing there, in a room built for newborns. And it wasn't alone. Astronomers eventually found 6 of these, objects glowing with the light of up to 10 billion suns worth of stars, formed in less time than it should take to build even a fraction of that. To make one of these galaxies work under the old rules, you'd need almost every single atom of gas in that region to instantly convert into stars, a conversion rate physics doesn't allow. So either something built these galaxies faster than we thought possible, or something else is hiding inside that light, something we haven't identified yet. Stop here for a second. This isn't a rounding error. This is a telescope looking at the beginning of time and finding fully formed structure where there should have been almost nothing at all. And it gets stranger, because the problem isn't only what's inside the universe, it's the shape of the universe itself. There's a rule cosmologists have relied on for a century. Zoom out far enough, and the universe should look the same everywhere, evenly spread, no favorite direction, no special regions. It's called the cosmological principle, and a physicist studying it once said that without this one assumption holding true, all hell would break loose in the field. In 2024, a doctoral student found something that isn't supposed to fit inside that rule at all. A ring of galaxies 1.3 billion light-years across, curling through space in something close to a perfect circle. Picture the entire diameter of that ring as a single heartbeat of light traveling at the fastest speed anything can move, and it still takes over 1 billion years just to cross from one side to the other. It sits right next to another impossible structure, the giant arc, nearly 3 times larger than theory says any structure should ever get. They're not on opposite sides of the universe. They're neighbors. Some scientists push back. Maybe these are just illusions, random points our eyes connected into a shape that isn't really there. But even the skeptics admit something else, something harder to wave away. The shapes aren't the only thing pointing in a suspicious direction. The light of the entire universe seems to be pointing somewhere too. Scientists studying the oldest light in existence, the leftover radiation from 380,000 years after the beginning of everything, found an alignment in it that shouldn't exist. 2 specific patterns in that ancient light line up with each other in a way that pure randomness should never produce. They nicknamed it, only half joking, the axis of evil. Here's what should genuinely unsettle you. When researchers compared that axis to several completely unrelated cosmic measurements, the alignment of distant quasars, the spin of galaxies, even the tiny regional variation in one of the fundamental constants of physics, all of them pointed, within a few degrees, toward the exact same direction in space. Different instruments, different phenomena, different research teams, on different continents, who weren't even looking for each other's results, all pointing at the same spot. Which brings us back to where we started. Those spinning galaxies from the opening, the ones favoring one direction over the other, 2 to 1. In the deepest image ever taken, one explanation on the table is almost too strange to say out loud, that our entire universe was born inside a rotating black hole, and it inherited that spin. The astronomer behind the study said the pattern is clear enough that anyone looking at the raw image would see it with their own eyes. No statistics degree required. Sit with that. Not a subtle statistical whisper buried in data. A pattern visible to a human eye, in a photograph of the edge of time, suggesting the universe itself might have a direction it was born spinning in. Here's what these 6 cracks actually add up to. Once you stop looking at them one at a time, we don't know how fast the universe is expanding. We don't know if the force driving that expansion is even constant. We've photographed galaxies that broke the rules for how fast structure is allowed to form. We've found shapes in space too large for the universe to statistically produce more than once, sitting right next to each other. We've found a preferred direction baked into the oldest light that exists, matching up with completely unrelated data. And we found a spin in the fabric of deep space that shouldn't be there at all. Everything we assumed we understood, the rate, the uniformity, the timeline, the neutrality of space itself, all of it rests on one quiet assumption nobody questions out loud, that the tiny corner of the universe we can actually observe is a fair, honest sample of everything else. But we've never confirmed that. We've never been able to leave our galactic neighborhood in check. Every single measurement humanity has ever made about the universe was taken from inside one small, moving, spinning position within it. So ask yourself this, honestly, if every tool we have to measure the universe is standing inside the same tilted, moving room, how would we ever know what part of what we're seeing is the universe, and what part is just the room? There's a deeper version of this discomfort in physics itself, at the smallest scales instead of the largest. Some physicists argue the universe can only be one of 2 things. Either it has fixed, definite properties whether or not anyone is measuring it, or it only takes on definite properties the moment something looks. It cannot be both. And we may never have a way to point outside the system far enough to find out which one is true. We are inside the experiment, measuring the experiment, using instruments built inside the experiment. There may be no way to step outside long enough to check our own math. That spinning pattern from the very beginning of this video wasn't a glitch in the data. It was a small, quiet suggestion that the room we live in might have a shape, a direction, a history we were never in a position to notice from inside it. If that unsettled the way you think about the sky above you, That's exactly what the like button is for. And if you want to keep following these cracks all the way down, subscribe. The next one goes somewhere the math can't fully follow.